year 1851, a hero was born in Framlingham, England. His name was Rupert Scrivenbottom. Now, the Scrivenbottoms were a rather plebeian family with a rather plebeian past. Mrs. Scrivenbottom stayed at home and knitted all day long. Mr. Scrivenbottom worked at the local lamp factory lifting oil as a manual labour hand. When young Rupert was born, they did not expect much of him, and neither did anyone in the town. But as he grew, it became clear that Rupert was no ordinary boy. Rupert began speaking at the ripe age of 7 days. As he grew, so did his brain, and soon he was taking on the challenges of beginner's algebra. At only 3 months, young Rupert began to add to the budding field of calculus. On a fine spring day, his dear mother carted young Rupert down to the shipyards to see his father. Rupert found great joy in watching his father work at the fields. But one day, young Rupert got a glimpse of something peculiar. Sir Scrivenbottom's load of oil had been filled more than usual. Understanding from his prior studies that work was the integral of force, Rupert decided it may be a good idea to figure out the exact amount of work needed to be done in lifting this leaky oil bucket. After looking at his dearest old father, he calculated that his father had no more than 1,200 joules in his feeble old muscles. Young Rupert knew that if the bucket required more than 1,200 joules to be lifted, his father would not be able to complete the task. If he could not complete the task, the oil bucket would slip, fall, and land on the candle, and all of Framlingham would go up in flames. Rupert figured that in calculating the amount of work required to lift the bucket, he would need to split each aspect of the bucket being lifted into different pieces. Rupert knew that in calculating the total work, he would have to look at the work involved in lifting the bucket alone, as well as lifting the leaking oil, as well as the work involved in lifting the rope, and finally, the collective work in lifting all three. Being a master approximator, Rupert looked at the thin pail and determined it to be no more than 23 newtons empty. The pail was to be lifted 15 feet from the base of the camp to the top of the second floor. The mass of the bucket and its force being 23 newtons, in calculating the total amount of work in lifting the bucket, one must integrate the weight and force of 23 newtons. From 0 to 15, the total height it is lifted. The integral of 23 being 23x, then calculated on the interval of 0 to 20, would equal a total of 345 joules. Rupert then approximated the amount and mass of the oil inside of the pail. Rupert approximated the total weight of water to be 100 newtons of force. He then multiplied this weight by the proportion left at elevation x to get the total force in lifting the bucket. Rupert observed that each bucket typically had 1/2 its volume at its top that it had when it initially started to be lifted. Young Rupert then calculated the proportion left at elevation X to be 15 minus 0.5x all over 15. Finally, Rupert was able to put together an expression to determine the force required in lifting the oil. This expression was 100 minus 3.3 repeating times x. The integral of this expression from 0 to 15 would give Rupert the amount of work required to lift the leaking oil. This integral was found to be 100x minus 3.33x squared over 2 from 0 to 15. Rupert found this value to be 1,125 joules. Next, young Rupert had to determine the amount of work required in lifting the rope. Young Rupert approximated the rope to weigh 0.4 newtons per meter. Rupert recognized that the force required to lift the rope was variable, just like the oil. By multiplying the mass of the rope times the changing length of the rope, Rupert would be able to calculate the force. The force would be 0.4 times the quantity of 15 minus x. Rupert then integrated this expression from 0 to 15 in order to calculate the total work. Rupert found the integral to be 6x minus 0.2x squared from 0 to 15. When calculated, Rupert found the total work to be 45 joules. Rupert added the 1,125 joules required in lifting the oil to the 45 joules required in lifting the rope, and finally to the 345 joules required to lift the bucket. Rupert found the total collective work to be 1,515 joules. This was far more than his dear old pa was capable of lifting. Rupert flew into action to save the bucket from spilling and leaking oil all over the fire, which would burn the entire town down in flames. So Rupert flew up to his father with his mighty steps and sat on his shoulder and helped his father pull. Together they pulled, and the bucket was brought to the top, and the city was saved. All the village folk rejoiced, and it was a happy day, and that was the very day that Rupert Scrivenbottom became a hero.